Okay, so you're welcome to the lecture today, CHM 316. So let me just share my slides so we can go on. Okay. Please, we don't want distractions, please. We don't want distractions, please. We're live on YouTube. So lecture is starting now. So I welcome you to the lecture today on CHM 316, Methods of Chemical Analysis. So our lecture 1 is on gravimetry. I want to know if you're hearing me. Is everybody hearing me? Somebody should respond.
Yes, ma'am.
Yes,
okay.
ma'am.
All right, so our lecture 1 is on gravimetry. So gravimetry is an analytical technique where the quantity of substance is determined by measuring the mass of that sample, the substance in a sample, or the mass of a specific component of the sample, of the substance in that particular sample that we're looking at. So this method is one of the most accurate techniques in determining the concentration of a substance in a sample. I'm talking of gravimetry. And the key concept is that the substance of interest can be isolated by precipitation, and the mass of the isolated substance can be used to calculate the amount of that substance that is present in the original sample. So today's lecture, or in the lecture here under gravimetry, we'll be looking at the principles, methodologies, the different types of gravimetric analysis, the applications of gravimetry. Also, we'll look at some examples, and then the key concepts of gravimetry and the common sources of error. So why carry out gravimetric analysis? The objective of carrying out gravimetric analysis is to determine the quantity of analyte in a sample by precipitating it into a solid form. And then you weigh it and know the weight, and then you use that to calculate the mass. And this method, the gravimetric method, is used when you require high accuracy and high precision. So principles of gravimetry. Just hold on, let me be admitting people also. So the principle of gravimetry, gravimetric methods are based on the principle that mass of a substance can be determined by its weight using the influence of gravity. And just hold on a bit for me. I need to admit people into the class. Just give me one moment. Let me admit these people into the class. So please, in the next lecture, try and come in 5 minutes to the lecture so that we can start and concentrate without this distraction of admitting people in. Okay. So I think we should go ahead. Okay, so we're looking at, sorry, let me see, I still need to admit more people. Just next 1 minute, I'll just come back to the lecture. I'm sorry about this. This next time coming on time. Okay. We want to look at the principles of gravimetry. Say is based on the principle that mass of a substance can be determined by its weight using the influence of gravity. And we have some basic principles, which are: one, the law of conservation of mass. So gravimetry is based on this principle, law of conservation of mass, which states that mass cannot be created or destroyed. It's also based on stoichiometry. In this case, the quantitative relationship between the reactants and the products in a chemical reaction is very, very crucial in calculating the mass of the substance accurately. Also, another basic principle is gravimetric, gravitational force. So in this case, based on the fact that the weight of a substance, which is a force exerted by gravity on an object, is related to the mass of that substance. And so in this case, the relationship is the weight is equal to mass times acceleration due to gravity. So I think I need to, sorry, I have to go and admit people again. Please, next time, let's come in on time so that we'll just face our lecture straight because of distraction of admitting people into the class. Just hold on a bit, we'll go back to the class. Let me admit your colleagues in. Hold on a bit. This next time, try and come on time. Okay, I have to go back to the class. Okay, so we have seen the principles of gravimetry, law of conservation of mass, stoichiometry, gravitational force. So let's look at the steps that are involved in gravimetric analysis. Here, first one is preparation, sample preparation. So what we do is that the sample is first of all dissolved in a soluble, suitable solvent. Mostly water. Water is the solvent that is used, or it can be dissolved in an acid. so as to have the sample in the proper chemical form for precipitation. That's the first step. And then the next step is to form the precipitate. Of course, we, like I've told you, the basic principles and so on, we're supposed to form the precipitate and then weigh it out and do calculation. So next step is to form the precipitate. And in this case, we have to add a precipitating agent, a reagent that is going to precipitate the analyte out and bring it out in solid form. I'm distracted because of admitting, I'm still admitting people. So I'll soon stop admitting them and we face the lecture. That's why I need you to be coming in on time, please. Next week, we have to be here. Even from 10 minutes, you can join. I will come on time and then get everybody in so that before the time we start, we'll just face our lectures, please. Okay, so I'll go back to the lecture now. I'll stop admitting and go back to the lecture. So now we've talked of the preparation, the formation of precipitate. In this case, an example is that one of if our analyte is chloride, we are looking for chloride in a sample. We know how much is there in that sample. So we use silver nitrate as the reagent that will precipitate out our chloride. So this is an example. And then when we add silver nitrate to the solution containing our chloride, it will precipitate it out and a reaction will take place. And then we have silver chloride, which is solid. That's the precipitate that we'll have, silver chloride. And so the next step is the filtration. So we have to filter out the precipitate from the solution. The precipitate is formed, but it's still inside that solution. And so we have to filter it out. We can use ordinary filter paper with funnel and conical flask. We can use that, but the best to use is vacuum filtration, which we need us to use something like a Buckner funnel and then the pump, suction pump, which I'm going to show you any moment now. Please give me another 1 minute to admit your colleagues. So many people are still outside. Let me just admit them in. Okay, I think we're almost there. I think I don't have many people again to admit. Oh, they're still coming in. Okay, go back to the lecture. So we're talking of filtration, which I'm going to show you a setup very soon on how to carry out filtration. Yeah, after filtering, it's very important also for the precipitate to be washed, because when you filter, the solution where it was in is still having contact with the solid precipitate that you have. And so what we need to do is wash the precipitate. Mostly we use distilled water to wash the precipitate and remove that soluble impurity. What I mean by soluble impurity is a part of the solution where the precipitate was in. So we wash it completely over and over and make sure that all those soluble impurities are removed. And then after that, we dry the precipitate, dry it in an oven, and then, or you just put it in a crucible and dry it to remove the volatile substances or moisture. This drying is carried out under controlled temperature. The reason is that you don't want your precipitate to be decomposed. You don't want to dry it and decompose it. So you dry it under a controlled temperature. Please, can you mute yourselves, please? Everybody should be muted. Everybody should be muted, please. Hello, can you mute yourselves? So, after drying, then the next step is to wait. The next step is to wait. Let me just admit 2 people here that are still waiting. So what you do, you take the precipitate to analytical balance that is having high precision and weigh. Then you get the weight, you get the mass of the analyte in the sample. The next thing you do is calculation. Remember I mentioned to you that it's important, key things, one of the key things important is the stoichiometry. So we're going to use stoichiometry to carry out the calculation to get the exact mass of the analyte in the sample. So in this case, the molar mass of the precipitate, it should be known. And then you use that to calculate the mass of the particular analyte you need in your precipitate. So this is a typical setup here. And here it's a particular example I want to give you here. If we're looking for fluoride in a sample, what you do is you dissolve that sample. Take a known amount of that sample, should know the exact weight, mass, weigh it, and then put it in a beaker or whatever you're using, dissolve it. Like I told you, you can dissolve it you can use water to dissolve it or an acid, depending on what sample you're dealing with. Then, you have to add a precipitant. You add something that will precipitate it out. In this case, we have lead chloronitrate. We're adding here to that solution that contains chloride. And then it will form the precipitate here. And then you can see then what you do next is to filter the precipitate out, and then you move it there to drying and weighing. So next now, this is just a typical setup of gravimetry, and even showing you. Now, key considerations in gravimetry. These are key considerations in gravimetry. The purity is very key. Please give me time again. Let me admit your colleagues in. I still have some people here. So just less than 1 minute, I will admit them all in. One person is still waiting. Okay, so there are key things we must consider when we're carrying out gravimetry. And one is purity of the precipitate. That precipitate must be very pure. It should not contain impurities or even co-precipitated species. Those are going to add to the mass of what you're measuring, and that will not be the proper result. And I don't know, people are just still coming in and distracting us. Okay, so the next key thing you must consider is that you have to carry out complete precipitation. Because if you don't precipitate everything of your analyte that is inside that solution, if it is not all precipitated out, then it means that you're going to lose some. The results cannot be complete. You will not have a good result because the mass you're looking at will not be the actual mass of what is there, because some of them will be lost. So another one is filtration efficiency. Proper filtration technique is very important to show that the precipitate is not lost or contaminated during separation process. So when you carry out filtration, like I showed you, it's good if we use Buckner funnel and the vacuum suction and so on. That is easy. It is fast. You make sure that everything is out. It's all filtered out and you don't have anything you're losing back into the solution. So that is another key thing, filtration efficiency. Then accuracy in weighing. You use an analytical balance. That is good. You just don't use any balance. Analytical balance that have high, that is give you high accuracy and high precision. So I'm still admitting your colleagues. Okay. So now the next thing is, we have different types of gravimetric analysis. I mentioned to you before, we have precipitation gravimetry, we have volatilization gravimetry, and we have electrogravimetry. So I've already explained to you much about precipitation gravimetry. So what I have here is just like a repetition, because what I gave you about gravimetry was just a general thing, but mostly on a precipitation type. So, but now looking at precipitation gravimetry on its own, it's just the same thing that what I explained before. But there are some key things you must pay attention to. And selecting your precipitating agent is very important. So you select the precipitating agent that will that is specific, that will specifically isolate out the particular analytes that you need. And that precipitating agent itself must be of high purity, And this is important because without impurities, with impurities, you will not have the exact amount of mass of what the result will be. It will give you error. You will have the result, but it will not be representative of what you're actually looking for. And then the precipitate, why you need to select your precipitating agent properly so that you will have the good precipitate. And then the precipitate has some properties. They have to be of very high purity. Precipitate has to be highly stable. Stability of the precipitate is very important because otherwise you get precipitate, and along the line as you're processing, it gets dissolved, and then back. Some of it will get dissolved back if it is not stable enough. And then what you have the reduced quantity. Then also your precipitate must be of low solubility. So if you have selected your precipitating agent well, so that it will precipitate everything out, and the precipitate comes out with the good property, which is of low solubility, then this is good. You're aiming at the proper, accurate result. So the precipitate should form, the reagents that you're adding should be the one that will form a precipitate with low solubility to ensure that most of the analyte is removed from the solution. Most of the analyte has to be removed from the solution. So, and I think, I don't know whether I've mentioned this. So I've already talked of the processes, precipitation, then digestion is also important. After you have your precipitate, what you do next is to heat. You heat the precipitate to improve particle size and filtrability. Heat it, and it will improve the particle size, and it will make it, to be well filtered. So, and this process of heating the precipitate to improve particle size and filtrability is called digestion. So next one is filtration. I think I mentioned, and the washing. And then there's something I want to say about that washing. It's very important that you wash the precipitate properly and remove everything. Otherwise, if you don't wash it well, there'll be other attachments, other impurities that will be there. By the time you weigh it, you have a higher quantity than what you're supposed to have, and the extra quantity is from the impurity, which is creating error. And so this is important. Then the drying, I've already talked about it, and the weighing, I've talked about it in the general gravimetric process. So we paid attention to this. And then I talked about using effectively, if you're doing your filtration, to get a proper filtration, it's best to use the vacuum pump. Using the Buckner funnel, vacuum flask, and filter paper, and then with a vacuum source. I will show you a setup here that explains all what you see on this slide to make it easier. So you can see this setup here. Here is the vacuum flask. It can be in the form of a flat bottom flask like this, or it can be a round bottom flask. It can come in different sizes. You can use whichever size fits the amount of sample, the amount of solution that you're handling. So, and then by the side of your vacuum flask, there is an opening. So you have a rubber stopper with a hole, which is used to connect the flask to a vacuum tubing. So as you can see here, and then the tubing is now linked to a suction pump. This suction pump is the source of your vacuum. So when this suction pump is switched on, it draws, it applies pressure and draws the liquid that you put. This one, the white one on the top of that flask, is the Buckner funnel, where you pour in your liquid, the liquid that is containing your precipitate. You pour it in there. There's a filter there inside the Buckner funnel. And so then you pour it in and you switch on the pump and it pulls in the liquid and draws it in. And so you have your filter, your precipitate on the filter that is in the Buckner funnel, and the filtrate, the liquid, goes into the vacuum flask. So that is how it works. And so, of course, that's why I say you know the amount of filter or the solution that you're handling, and that will determine the size of the flask that you use. So what I've just explained to you is what you see here on this slide. So, and then the suction helps to speed up the filtration process, and it also ensures that more complete separation of the solid from the liquid is achieved. So let's look at a typical example here of determining chloride here using silver nitrate. Example, I mentioned it earlier some slides back, but here this is how it works. So the solution containing the chloride, the aqueous solution, and then the silver nitrate is also aqueous solution, and then reacting them, you get your silver chloride. Silver chloride is a white insoluble precipitate. The procedure, how you do it, what you do is get a known mass of the sample and then dissolve it in water. Let's say it is sodium chloride. That's the sample. And it contains chloride inside. So you just dissolve it in water. And then the excess silver nitrate solution, you're talking of as the one that is precipitating the chloride out, is added. And then this forms silver chloride precipitate, the white precipitate we're talking of, insoluble. So precipitate is filtered just like what I showed you before, using Buckner funnel and the suction. And then it is washed and dried to remove excess silver nitrate and moisture. How do you wash it? How do you wash it? So you pour in this case, we're talking of using distilled water. The filter, the precipitate is already inside your Buckner funnel on top of the filter on the Buckner funnel. So what you do is just pour distilled water in there and still use the suction and draw it. That's how you wash and wash and wash. And then you have clean precipitate on the filter. Now, the next now, just trying to show you what happens. Just a schematic representation of what I just explained to you is just what I'm showing you here. So the silver nitrate dissolves in water, and then sodium chloride dissolved in water, and then the sodium chloride dissociates into sodium ion and chloride ion. And then the reaction takes place when silver nitrate is added to the solution containing the chloride ions. The reaction occurs and results in the formation of the white precipitate of silver chloride. So this is just exactly what I explained. The silver itself, the silver ion is colorless. The chloride ion also is colorless. And so when they combine together, they form that white, solid white precipitate of silver chloride. It is insoluble in water. That is why you can use water to wash it, to wash the precipitates that I said is to be on the suction, on the Buckner funnel filter. So then you weigh it, dry it, and weigh it, and then get the mass. So how do you do the calculations? The next thing is the calculation. So So from the mass of silver chloride precipitate you have, the number of moles of silver chloride is calculated. Now this explain, I'm going to use this to explain what I meant before, that stoichiometry is very, very key and important in gravimetric analysis. So we're going to use stoichiometry here. So here in the stoichiometry of that reaction between sodium chloride and silver nitrate, we had the reaction. When you balance, to be able to get that stoichiometry, you balance your equation to know how many number of moles of reactants reacted and to form what number of moles of the product. So in this case, it is 1-to-1 ratio. It is 1-to-1 ratio. So the number of moles of chloride in the original sample is the same as that of the silver chloride. And the mass of chloride can be determined by multiplying the moles of chloride by its molar mass. I believe you understand this, you know this from your experimental work. So let us see now what is given to us in this case. We are given the mass of silver chloride precipitate as 0.545 grams. We are given. And then you know that the molar mass of silver chloride is 143.32 grams per mole. And then the molar mass of chloride is 35.45 grams per mole. So having been given this information, now we can carry out the calculation. So step 1, let us find the moles of the silver chloride. Moles of silver chloride is the mass over molar mass. You know the definition already. Mass over molar mass. So that gives us 0.00380 moles of silver chloride. Remember, we said the mole of silver chloride is the same. The chloride is equal to the mole of the silver chloride is the same as the mole of the chloride. So our second step now, find the mole of the chloride, which is equal to the mole of the silver chloride. So the mole of the chloride is also 0.00380 moles. Now the step 3 is to find the mass of the chloride. That's what we're looking for now. So the mass of the chloride, from the definition that we all know, that mass is moles times molar mass. Moles times molar mass. So the number of moles of chloride here, as we have calculated here, is 0.00380 moles. And the molar mass, as we know, is 35.45 grams per mole. So you multiply it and you have the mass of chloride in that sample. So that means we have 0.1345 grams of chloride in the sample of in the silver chloride precipitate of the gram 0.545. So now that is how we carry out precipitation type of gravimetry. And then there are advantages of gravimetry. One is high precision. Gravimetry is one of the most precise methods of quantitative analysis. Another advantage is that there's no need for calibration curves. Since the method is just based on direct mass measurements, there's no calibration, external calibration that is required. Another advantage is that that of simplicity and reliability. Method, as you have all seen from what I explained, very simple. You use very simple equipment, just balance, filtration setup, the drying furnace or so. So the equipment are very simple. Oh, I'm sorry. So many people are still in the waiting room coming this late, and we're almost done with the lecture. Let me still admit them in, please. Many people are still waiting. Please coming into the lecture. Since we have so many people, the class is a large class, so please, 10 minutes to the beginning of the lecture, I'll be here waiting. Everybody can just come in, please, on time, so that we're not slowed down or dragged back. Okay, so I'll continue with the lecture. But also, of course, you know, we're live on YouTube. So when I'm done, I'll give you the link so you can go back. If you missed part of it, you can go back and watch. And then also, the advantage again is that of low detection limit. You can detect very low concentrations of analyte. You can detect it with this gravimetric method. Though it has advantages, there see some disadvantages. People are still waiting here. Oh, okay, I'll just admit them. Just one few seconds. Okay, I'll go back to the lecture. So the disadvantages, you know, as you can see from all the explanations I made, it's time consuming. Procedure requires steps including precipitation, filtration, drying, and all those take long time. Another disadvantage is we require very pure reagents. If the reagents are not pure, of course, impurities will add up and it will alter the mass that you're supposed to get. It's not going to give you good results. And then interferences from impurities also. Any contamination or impurities can affect the results, especially if there's co-precipitation. Another thing, precipitating also, adding to the analyte that also precipitated. So that is another issue. And also another disadvantage is that it's not suitable for all substances. Some substances may not form suitable precipitates or may be difficult to filter or weigh. So that's another disadvantage. People are still waiting. So let me admit them. So these are the different common precipitates used in gravimetry. One is that one we just discussed, silver chloride, which is used for chloride and ion analysis. Then we have another precipitate, barium sulfate, is used for sulfate ion analysis. We have calcium oxalate, is used for calcium ion analysis. We have iron 3 hydroxide, which is used for determining ion in a sample. So there are sources of error in gravimetric analysis. So even though we know that gravimetry has high precision, there are several factors that can introduce errors while we're carrying out gravimetric analysis. So one is loss of sample. During filtration or washing or transfer from one apparatus to another, some of the precipitates may be lost, leading to an inaccurate mass measurement. Another source of error is incomplete precipitation. If the precipitation reaction is not complete, of course, you know that the analyte may not be completely captured because not all of it has been precipitated out. So then this will lead to underestimation of the mass of the analyte that you're measuring. So Another one is contamination. If the precipitate is contaminated with impurities, the mass of the precipitate may be higher than expected. And so this destroys the result you're having, tampers with the results. Another one is inadequate drying. If the precipitate is not fully dried, you still have some residual water, so it will add to the weight, leading to overestimation of the mass. And then another source of error is impurities in the reagent. So you introduce from the reagent, say you have your silver nitrate and it's very impure, and then you introduce that impurity into the reaction, and so the precipitate itself gets contaminated. And then, or washing can affect the purity of the precipitate. Maybe you use something that is also already not pure. So those are the sources of error in gravimetry. Let's see here, admission into the class. It will soon be done with the class. So that is the end of the lecture for today. But lecture is on YouTube. I'm gonna give you the link to the lecture so you can go back and watch. I don't know if somebody has question. I don't know if anybody has it.
Ma'am, please, can we get the slide?
Okay, I will send the slides to you, but also you can see it in the recording, but I'll send the slides to you.
Okay, thank you, ma'am.
Okay, somebody is still coming in meeting at this time, please. This is very important. In our next lecture, please come 10 minutes to the time so we're able to admit all the people. And
right. Hello, Ma.
Yeah.
So I can see some people dropping their matric number on the comment section. I just want us to be sure if you give an instruction to do that.
I did not, but I've seen that I have 163 people here in the class. So
all right, Ma.
Yeah. All right. So I will send the lecture notes, and also you can watch on YouTube. Okay. All right. So next lecture will be a continuation of the gravimetry, and then I'll also be taking you on UV spectroscopy. All right. Thank you and have a blessed day.
Thank you, Ma.
Thank you, ma'am.
Yeah.
Thank you, Ma.
Thank you, Mom.
Okay.
Thank you, Ma.
Bye. Okay.
Bye.
Yeah. Bye.
Bye.
Bye.